Hello and welcome. In this short tutorial, I'm going to show you how to use the automatic mesh convergence tools in Ansys Mechanical. We're going to use this geometry, which is a simple plate shown here. To begin with, I'll come and do a mesh, and I'll just use the default mesh, and I can see that that mesh is pretty good. I can come over here to the details of the mesh and click on this use geometry setting and look at the element quality. I can see that my element quality down here near the radius is 0.74, but throughout the majority of my body I'm up around 0.99. I can scroll to the bottom of this and look at the statistics, and I can see that I have 2,370 nodes and 411 elements. So I'm going to go ahead and use this as my mesh to begin my analysis before I do any convergence. So the next thing I'll do is come to the static structural and enter in the boundary conditions. I'll put a displacement on this face in the X direction of 0, and I'll put a displacement on this face in the Y direction of 0. And then on this front face, I'll put a displacement in the Z direction of 0. Now I'll come and put a force on this back face, and I'll put a force on there of 500, and I'll click on vector and put it in terms of components, 500 newtons in the X direction. So I now have my model built. I can look for the outputs. On the outputs, I'll pick stress, and I'll pick on the equivalent stress, and then deformation directional, and I'll go ahead and click solve. I can look at my equivalent stress, and I can see that my equivalent stress is highest near this radius. I can see that it changes throughout the structure a little bit, and I can see that my maximum value is 6.13 e to the 6. I can also look at my directional deformation, and I can see that it's largest on this back free end. To do a mesh convergence, what we will do is come to the equivalent stress, right click on it, insert, and then come down to convergence. We can see that it's introduced this new line in our project tree, and it's opened up a convergence history window. This number over here, the allowable change, is what happens is when I click solve, Ansys is going to continue to refine the mesh and come up with solutions until the solutions stop changing within this percent value. So I could still have answers changing up to 20% if I leave this at 20. I'm going to change this and put this down at 5%. So now Ansys will continue to refine the mesh until the answers fall within 5% from the previous solution. So now when I click on solve, Ansys will go perform that mesh convergence. I can see that my equivalent stress now has changed from 6.13 to 7.5, which is a 20.37% change. I have gone from 411 elements to 3,066. I can click on the equivalent stress, and I can see how my mesh has changed. I can certainly see the increased mesh density around the radius in my plate. So I'm going to come back to convergence, and now I'm going to click on the allowable change as being 1%, and I'll click enter, and then I'll click solve again. And Ansys will go iterate on solutions until they have converged to within 1%. I can see that I'm starting to form a line here that is looking to converge to a number. This last convergence only had a change of 4%, but I went from 3,066 elements up to nearly 15,000 elements. So I'm going to go ahead now and change this allowable to 0, and then hit enter and click solve. This solve will take a few minutes, so I'll hit pause. Now that I've obtained this result, I can see that I had a 0.2%, a negative 0.2% change I went from 14, nearly 15,000 elements up to nearly 60,000 elements. I could hit converge again here as well, and it would increase the number of elements and continue to give me a convergence. So I'll go ahead and do that and hit solve one more time. Now, having done that, I can see that I've gone from 411 elements up to 155,000 nearly elements. But I can see that I have a converged solution where my value changed steeply and then I plateaued here. So certainly there would be a trade-off between solution time and quality of result, and that is what the engineer needs to decide to do. So I can come and look again at my equivalent stress, and I can see the mesh that has been developed. I can see a lot of extra elements that were developed out in this region that probably weren't needed. And I can also see an extremely high mesh density in this region. So that shows you how to do an automatic mesh convergence